Okay, Algebra 2, we are going to be graphing again to find our system's answer, our x equals, but now we also have a y equals because notice in our system, we not only have an x like in 1.5, we also have a y. We have two variables in this system of equations. We're going to graph these, but they're not in slope-intercept form, so I'm going to do that down here. We want to get y by itself for the purple equation. We're going to minus 4 to both sides, and I'm going to write negative 4x first, just to keep the slope first, and then the intercept. So positive 9 is plus 9. Over here we have a plus y, so the y is already positive over here. We don't have to worry about it. We have green down here, so we're going to minus 2x to both sides. So we have negative y. Notice there's still a negative in front. Equals, I'm going to write the negative 2x before the plus 9. I need that y to be positive, so in order to change something to a positive, we're going to divide by negative 1, divide everything by negative 1, so we flip the signs on all three of these, so y equals 2x minus 9. We can graph both the purple and the green where these two graphs intersect. That's going to be our answer. Different than 1.5, we have two variables like we said, so we need both the x value and the y value for our answer. Before we jump into the next examples, we have this key that you could write down for shading. It'll make sense in a little bit, but when you have y is greater than, it's a dotted line, a dashed line, and you shade above because it's greater than the line. Y is greater than or equal to. The equal to means we have a solid line. It's still greater than, so we're shading above. Y is less than, dotted line because it can't be equal to the line, and we're shading below because it's less than. And then y is less than or equal to. We can be on the line, so it's a solid line, but we can also be below, so we shade below. We shade less than. All right, we have a system of 4 equations here. The red and the purple, you can see the work below, but we're just solving for y so that we can graph it. The one thing that I do want you to notice we have inequality signs instead of equal signs. That'll doesn't play into how we graph the line, but we do use this key back here to figure out if it's dashed or dotted and then where to shade. The one part I want you to notice down here, we have a negative y, so we're dividing by negative 1, just like in the first example. We have to divide by negative 1 to get the y positive. But with inequalities, when you divide by a negative, you need to flip the sign. So it turned from greater than, so y is greater than, to now it's y is less than. So when you divide by a negative, you got to flip the sign. Okay, we're going to graph the red. So up 7, then the slope is negative 1, so it's going down 1 over 1. For the purple, y-intercept is 2. We're going up 4 over 1 for the slope. For x is greater than or equal to 0. And notice, there was no equal sign underneath these, so they're dashed lines, they're dotted lines. The green one, x is greater than or equal to 0. So when x is 0, so on the x-axis, where's 0? It's right here, and we're going to go straight up and down because even if I'm up here, the x value is 0. If I'm down here, the x value is 0. That's a solid line, and we're going to be to the right of it because x is greater than. And then y is greater than or equal to 0. So on the y-axis, we're finding 0. Y is still 0 over here. Y is still 0 over here. The x's are changing, not the y value. Y is still 0. And it's a solid line, and we're shading above it. So where do all these 4 lines kind of meet? We would just shade in the middle right here. Last kind of concept, we have matrices. So we're going to have a system of equations. We have x, y, and a constant or a number, and we just want to create a matrix down here. So in the red equation, 3x plus y equals 0. We're taking the coefficients, 3, the imaginary 1, because we have 1y and 0, and we're just plugging them into a matrix. Where the equal signs are, I like to draw a solid line. Sometimes you'll see a dashed line, just kind of depends. Negative 1x minus 2y equals 4, so negative 1, negative 2, and 4. And then this last one's kind of tricky. We just have an x, and there's an imaginary 1, so we have 1. There's no y's right here. We're missing a y, so we have 0y, and then 6 would be our constant.